Hi, in this video, contents related to UAV sensors will be shared. Various sensors are needed for UAVs to operate safely and efficiently. Sensors play a critical role in drones by providing data for navigation, stability, obstacle avoidance, imaging, and communication. Each sensor collects specific environmental or mechanical information and sends it to the drone's flight controller, enabling autonomous or semi-autonomous flight. Basic sensors such as the inertial measurements unit, GPS, compass, and barometer are used to determine the UAV's flight status, position, orientation, altitude, and speed. Obstacle avoidance sensors are used to prevent collisions. Sensors like ultrasonic LiDAR, optical flow, infrared, and time of flight help the UAV detect objects around it. The pitot tube measures the drone's airspeed. Special cameras are used for different purposes. For example, oblique cameras are used for mapping, and multispectral cameras are used for agricultural applications. Special sensors are used for various tasks such as radiation measurement, gas detection, or weather monitoring. These sensors are integrated on the flight control board and supported by appropriate firmware to enable the UAV to perform complex tasks. The sensor that ensures the stable flight of UAVs is the EMU sensor. The EMU consists of a gyroscope and an accelerometer. The gyroscope measures angular movements such as pitch, yaw, and roll, while the accelerometer measures linear acceleration on all three axes. This unit detects change in the drone's status, helping it maintain stability. Additionally, the IMU provides real-time motion data to the flight controller to precisely adjust drone movement, ensuring a stable flight experience. The sensor that provides position data for UAVs is the GPS sensor. GPS plays an important role in autonomous flight modes by providing geographical location and altitude data for drones. It helps perform functions such as return to home, waypoints, and geofencing smoothly. GPS systems are divided into standard GPS and real-time kinematic GPS. Standard GPS is GNSS compatible and offer positional accuracy using multiple satellite systems such as GLONASS, Galileo, and Beidou. RTK GPS provides centimeter level accuracy, optimizing drones for more precision flight. The sensor that provides orientation data for UAVs is the compass sensor. The compass, also known as a magnetometer, measures the drone's direction relative to the Earth's magnetic field and works with the GPS to provide accurate heading information for navigation and return to home functions. The sensor that provides altitude data for UAVs is the barometric sensor. The barometer measures atmospheric pressure to determine altitude, which is necessary for the drone to hover at a constant height and maintain its altitude. Obstacle avoidance sensors include ultrasonic sensors, LiDAR sensors, vision sensors, infrared sensors, and TOF sensors. Ultrasonic sensors measure distance by sending sound waves and detecting their reflections, while infrared sensors detect heat differences using infrared light. LiDAR sensors use laser beams to measure distance with high precision. Vision sensors process images to detect obstacles and routes. TOF sensors determine distance based on the time it takes for light to travel to and from an object. The pitot tube measures the drone's airspeed. LiDAR sensors measure distance using laser pulses to create a three-dimensional map of environment, which is essential for advanced applications such as obstacle avoidance and terrain following flights. Infrared sensors detect heat differences, making them useful for night flights or thermal imaging missions. These sensors provide necessary functions based on the drone's mission and operating environment, enabling applications such as autonomous navigation, research, search and rescue. Ultrasonic sensors provide precision flight at low altitudes or indoors by sending sound waves and measuring reflection times. Optical flow sensors analyze image frames to track ground movement beneath the drone, contributing to stable flight when GPS signals are unavailable. TOF sensors use light pulses for distance measurement and are used in functions such as 3D mapping and collision avoidance. Automatic dependent surveillance broadcast is a system that automatically tracks the position, speed, and other flight information of aircraft in the air traffic. ADS-B receivers play an important role in UAVs. These receivers allow UAVs to detect other aircraft around them, reducing the risk of collisions. Additionally, ADS-B receivers enable UAVs to integrate into the air traffic control system, allowing them to operate safely in sensitive areas such as airports. ADS-B receivers also enhance flight safety. For example, if a UAV experiences a malfunction, other aircraft can detect this situation through ADS-B signals and take necessary precautions. ADS-B, an important data source for autonomous flight systems, helps UAVs detect obstacles, plan routes, and move safely within air traffic. Now, let's talk about the four main types of spatial camera used in UAVs: oblique cameras, multispatial cameras, hyperspectral cameras, and thermal cameras. First, oblique cameras are used to capture images of the ground and the side surface of the structures at an angle. These cameras are equipped with lenses inclined in different directions and offer a wide field of view, making them especially useful for mapping and urban planning applications. Multispectral cameras are widely used in agricultural and environmental monitoring, capturing data from multiple spectral bands for analysis. Hyperspectral cameras are used in advanced remote sensing and mineral exploration, providing high-resolution data with hundreds of spectral bands. Finally, thermal cameras measure temperature differences using infrared radiation, playing a critical role in search and rescue, structural inspection, and fire detection. There are also special sensors used in UAVs designed for different tasks in various applications. Drone operators need to understand how different electromagnetic signals interact with materials and sensors to maximize mission effectiveness. Radiation sensors are designed to detect and measure ionizing radiation, particularly useful in nuclear site inspection and emergency response station. These sensors are notable for their ability to detect different types of radiation, sensitivity, and energy range. Gas sensors detect specific gases or volatile organic compounds, playing a role in leak detection and air quality monitoring application. Detectable gas types, sensitivity, and response time are important features of these sensors. Air quality sensors measures various air pollutants and particles used in environmental monitoring and industrial inspections. Weather sensors measures temperature, humidity, wind speed, and direction, providing critical data for meteorological data collection and flight safety. The flight control board or flight control computer is the brain of the drone and process data from sensors to make all decisions during the flight. These sensors connect to the flight control board through specific communication protocols. Protocols such as I2C, SPI, and CAN bus ensure that sensor data is transmitted quickly and reliably. I2C is a low-speed, short-distance, bidirectional serial communication protocol. SPI is a high-speed, full duplex serial communication protocol. CAN bus is a reliable, real-time, fast, and interference-resistant serial communication protocol. These protocols enable sensors to communicate quickly and securely with the flight control board, supporting safe flight. In this section, we covered UAV sensor types and their functions. I hope the contents have been helpful. See you in the next content. Goodbye.